So last week, yeah, I guess I can say the presentation was a bomb rather than the bomb. So partitive article. It didn't go that great, or I should say, is like it took a lot longer than we expected, and I think we went a little bit off script. I suppose helpfully though. So hopefully the session will go a bit better. I think these notes
I
were
thought it went great.
a little
I
bit
just
tighter.
asked too many questions, so you can shut me up.
No, it's not that at all. It's not that at all, Rebecca. I think the one
Great
thing that
presentation.
I think the one thing that I learned from last week is to err on the side of practical. I think abstract doesn't work very well in these discussions, and I think like practical is even hard enough as it stands, because it may not always be obvious what's going on with respect to rlang. Yeah, last week not enough code, too many words. So I'll try to strike the right balance this week. So to kind of set things off, this week, the idea is to go over this vignette in the tidy evaluation overviews on data mask programming patterns. So last week we talked about data masking in general, what it is, why you might want to use it. Few little ideas on implementation, a few little features of rlang that exist. So this week is a lot more practical in the sense of how do you go about using it. And kind of to start things off, I'll start with what you can see on the screen right now. I think this is in pseudocode. My best understanding of what this vignette really talks about is, let's imagine you're an R developer. You're developing a function. You have, for your own reasons, some arguments that you want to have in your function, and those arguments, as we'll unpack shortly, have some associated behavior to them. And then inside of your function, you're going to use a tidyverse function. This is not obviously proper code here. Just imagine, substitute in for this your favorite tidyverse package, and here your favorite tidyverse function. But basically, you want to pass your arguments to a tidyverse function's arguments. It may be that you'll be able to pass your arguments unchanged to the tidyverse function, and things go great. That's the best case. But there may be other cases where perhaps you need to collect arguments in a different form than the tidyverse function expects. And so you'll need to do some manipulation or some clever thinking to transform your arguments into the type of arguments, notably arguments with the type of behavior that the tidyverse function expects. So the whole discussion on programming patterns is, how do you pass this in your function to the argument that's expected here in this function, such that this function can consume your arguments either unmodified or with some modification. Yeah, so that's my kind of overall understanding of the gist of this. I'll stop there and see if that makes sense, or makes at least enough sense for me to continue on.
Yeah, I actually usually reframe this the other way, in that I think about things where the tidyverse is designed to operate kind of outside of normal programming, in a sense that you can just type without quotations this object, and then tidyverse figures out how to handle it, right? And so that's cool, really cool, because when you do like select, for example, you don't need to like add quotations to every column you want to select. You can just type out the name of the column, and so there's like tiny bit of convenience that's added. But in return, in order to work with that convenience, we have, as programmers, as developers, have to figure out how to send it in a way that tidyverse would expect. So like there's like that, it's not just a data masking programming pattern. Like it's not just how do we get it that way, but it's because we're accommodating convenience that tidyverse level developing like expects, if that makes sense.
Yeah, no, that's a nice way to frame it, Tan. Yeah. I guess in shorthand meme form, with great power comes great responsibility, and the great responsibility is us to figure out how to hand tidyverse what it expects, so it can do the magic that we've come to expect of tidyverse.
Yeah, that's a really good way to phrase it.
And so I guess in this, you kind of noticed here that I kind of alluded to two parts of this kind of overall problem. One is behavior, which I've kind of talked about very vaguely, but not quite defined. And the other part is it, so function kind of arguments in this kind of context of working with tidyverse. Arguments have behavior that we're going to want to provide. So it's not just a matter of passing a character vector from one thing to another thing, but rather the tidyverse expects for its arguments that they be of a certain type and they exhibit a certain behavior. We'll come to that shortly. And secondly is there's this programming patterns part. So as I said earlier, in the best of cases, perhaps what you have in your function corresponds to exactly what tidyverse needs to consume, right? But there may be other cases where you'll need to do some manipulation so that tidyverse gets what it expects, and your function can get what it needs to get, which may be different. So really, we're going to be talking about kind of argument behavior and patterns. Patterns will be the bulk of the presentation, but I want to get the arguments part out of the to explain that first. So I think the docs really summarize it very well, or at least the vignette right here. So I'll just read what's on screen. In a regular function, arguments can be defined in terms of a type of object that they accept, right? So this is what we're familiar with normal kinds of functions. They expect an argument of a type. But in addition to this, in this context of work where kind of the consumer functions, like the tidyverse functions we have inside of our functions, they're working in this data masked context, things get more complex. So not only do we need to have the objects of the right type, but we also need those objects or the things that we pass to the tidyverse functions to have some kind of behaviors. What behaviors? There are a few that the vignette kind of describes rather briefly, but I think they become a bit more evident as we get into the patterns and the examples. So first is with data masking expressions. So you might have an argument that is a data masking expression that refers basically to columns in a data set, right? Rather than an object in the global environment. So that's a first kind of behavior that you could expect of an argument. So that if I provide as an argument a bare name, the expectation is that bare name refers to a column in a data frame. A very similar concept, which actually I'm not sure that I fully understand here, but I think for all practical purposes we can lump these two together, is the data masked symbols. So it's just, again, kind of the name of a column in a data frame, presumably a bare one here, although perhaps the distinction is that it's a symbol and not a bare name. The vignette doesn't go into this distinction, or at least I didn't quite understand this distinction, but let's just say, for simplicity, we've got data masking, and these are kind of two subcases of data masking behavior of arguments. A second type of behavior is tidy selection, where so we're probably all familiar with tidy selection, where you can have little helper functions will basically select columns within the data environment, maybe that start with something that contain certain strings that match a regex pattern, that are a member of a list, or rather like a vector of named columns. So this would be another kind of argument that has this computational behavior, since tidy selection performs a computation to basically select in the back end the columns that we indicate through some means. And then the last kind of argument behavior is with dynamic dots, where so it's kind of not. I think I'm gonna struggle here in defining dynamic dots very precisely, but if you have kind of dots in a regular context, it's just arguments of a function that you'll pass here. They're kind of dynamic in the sense that they could contain any list of things. So maybe like a series of variables to create a mutate operation, for example. So here we got data masked expressions, tidy selection, and dynamic dots. And if you want a little bit more, the docs have a little more content here about those particular things.
So Arthur,
Sure.
this, I'm looking at the vignette right now too, but this seems super important. Is that true? Like this is kind of the crux of understanding these are like the 5 main times in which this masking occurs, and maybe the second one is the only one I'm kind of sort of explicitly aware of. Is that a reasonable? I mean, not that you would know what I know or don't know, but the other 4 are. I mean, it just seems a little. I mean, I'm aware of dynamic dots and tidy selection and stuff, but it's a little bit more abstract to me about exactly where the masking happens and how it is dealt with. But this is what I should be like core understanding in order to understand masking in general.
I mean, I think this might kind of reduce actually to sort of three different kind of behaviors. At least these are the ones that appear in the docs. The vignette kind of points these out. As if you actually look in the docs, you'll find data masked as a behavior for an argument, tidy select as a behavior for an argument, and then dynamic dots as a behavior for an argument.
Cool.
And there are a few cases. I think I might have pointed to these even last week, but I just briefly was searching, I guess, in the wild for examples of these in the docs, and I think this is the point where we're discussing that whether this is new, old, or not. But I noticed in looking through the dplyr docs that now for some of these arguments, for example, that for mutate here, where you have the ellipsis, it explicitly says that what kind of object this is, and then the behavior it exhibits. So data masking. If you want to learn more about data masking, you can kind of click on this and understand a little bit more about it. So I don't know if this is helpful because it definitely does skirt over maybe the more theoretical parts, but for me, in a certain sense, it's maybe reductive and practical, but kind of if you're developing a function that utilizes a tidyverse function, probably you want to go to the docs of that function. Let's say you're using mutate, and you're going to be passing some arguments to mutate. You want to understand what mutate expects there, right? And so then you know that it's data masking, and it'll give you a better sense of what to do afterwards. And likewise for tidy select. So not surprisingly, select in dplyr, for these dots right here, it's unquoted expressions, comma separated unquoted expressions, and the behavior here is a tidy select behavior. And then for dynamic dots, this may not be the best example, but typical. If you're building a data frame, it's kind of a set of name value pairs, and they exhibit kind of a dynamic dots behavior.
Okay, thanks.
I don't know if that helps or further confuses, in honesty.
No, no, actually, that helps. Thank you.
Okay.
I think it's always been this way. I think too, there was an implicit question in here somewhere. It has always been this way, but I think they often got confused for each other. So I don't know if you've done package development, but it's only recently that they've started complaining when you use .data in the wrong context. So previously, people who were getting stuff onto CRAN would often use select, they'd use .data, $, whatever, and then just like list out all the things they want to select, even though they don't actually know like why it works. It just makes CRAN stop complaining.
Yeah.
Right. But what's happening is select actually doesn't do that. Select does tidy select. So it doesn't actually refer to anything in the column at all. It just does regex and computations over character strings. Whereas the data mask actually operates on said vector. So, people were kind of getting them mixed up. So I think that's also part of why things have kind of changed like this. And it now points at, this one uses tidy select. So you can pass it like character strings. And then this one uses data masking. You can use the .data pronoun. That's sort of how I think about it. It's similarly practical. But the reason they've changed the docs is because they used to do one or the other behind the scenes. Sorry?
इसके नीचे के बड़े लॉक की लॉक
Okay, I think we can
Uh,
go on.
Actually, Tan, can I ask one question about that?
Yeah.
So that is, you mentioned regex, and is there a way where would you find out how this is implemented? You know, like if I want to go to the function source code for, you know,
So most of
something,
the
I know
function
how to-
documentation says so.
Right, but how would I read the source? Where do you find the source code for data masking things? Like on
Oh,
GitHub
data masking.
or
Okay,
types like
yeah.
or dynamic dots? Like where do those show up enough?
I think we'll talk about the programming patterns, like how it's used. Is that sort of what you're after? Or are you
No,
talking about
I like looking at source code sometimes, right? So you just talked
Yeah.
about what was going on under the hood. Not that I can
Yeah.
always read source code easily, but where would I look under the hood for this? Because that is abstract to me.
Yeah,
Of where the
so
hood is, since
it
it's not a
previously
function
was,
itself.
it's always been there. It's just that like this is kind of, they've only updated the documentation recently to tell you what it's doing. And I think we'll talk about this shortly, but a lot of the forwarding patterns that we're going to look at are data masking. A lot of the name patterns are tidy select, etc. So I think that's what's happening. I'm not sure, but as far as like going into the source code, you can probably find a function that has, if you go to like the mutate function, Arthur is driving the screen, and then go into the source code. I'm not sure if there's a clear and obvious tell, but we can look at it and see if there is one. Scroll. Okay, so that says use method. So that's an S3 method. But this is what we want to look at. Okay, so it wraps the dots into this function called dplyr closures. This is new to me entirely. I haven't looked at this before. I think this is where like dplyr closures, if you can find it in this repository somewhere.
Oops, sorry. I meant to go up one level in the repo.
You might just need to search the repo itself. Use GitHub search to do that.
How do I do that? Actually, I saw John do that.
Very top.
Oh.
There's a shortcut, I think, but I
Okay.
just searched this and you just type out dplyr closures and then hit that.
Whoops.
Hit the S at the front and the side of the back. I need an S. There we go. Okay, so this is where it's all being used. Let's see if we can figure out where it's defined. Cross, oh, right there in a cross. You hit,
Oh yeah, sorry, so it is. Okay.
I actually don't know if this is going to be easy for us to understand.
Yeah, okay. I'm not trying to go. This is. I'm not trying
Okay,
to get
hang
too
on.
far
So
down.
see, so this is a pattern. This is the pattern we're going to be talking about really shortly.
Yep.
But you see dplyr closures. It then has, and it uses this function called new dplyr closure, which is listed above. This is like make dplyr closures for every element of dots. And then if you go up to the top, like up two functions or one function, two functions. It uses this list2 ... pattern to create like a closure with it, if that makes sense.
And so is list 2 going to be something that's defined?
Yeah,
in
that's an
rlang?
rlang. Yep.
Okay.
That's an rlang. And then we're going to talk about it shortly.
All
I
right.
think.
Thanks for the side effect. I appreciate it.
Yeah, of course.
Yeah, and actually, also June, I think in discussion
Mentioned it,
in
yeah,
chat,
talk.
yeah, he dropped a video where
finish it up.
I guess there's a little bit of I haven't watched the full video, but it looked like it was an attempt to sort of replicate tidy select just from scratch. It's not the exact implementation, but I guess I think kind of a neat idea of how it works behind the scenes. Right. So there are a few patterns. Actually, I don't go over this last pattern if time allows, and it may not. Maybe we could try to unpack this together. Actually, even sort of in the kind of textual table of contents in a certain sense, where the authors kind of indicate which the patterns are. They don't include the transformation pattern explicitly, but they talk about these three. So forwarding, names, and bridge. So forwarding is basically where you, like in broad terms, where you take your arguments and kind of directly inject them into the kind of the tidyverse function that's your function wraps, right? Directly inject it without modification. The names pattern, maybe I'm gonna, okay, rather than just try to describe these, let me describe these in due time. So forwarding, names, and bridge. Let's keep in mind those are the three. So we'll go over each in turn. So the forwarding pattern is where you're kind of forwarding the arguments from your function to kind of the outer function, your function, to the inner function, the function that you're wrapping. And there are a few ways to do that with either the embrace operator or with the dots, and we'll see each one in turn. So the embrace operator is really for the use case where you have a single, where you're forwarding a single argument, and it'll look something like this. So let's say you're wrapping summarize, a dplyr summarize, and you're just going to summarize one variable. So what you would do is kind of, rather than cite var directly as a bare name, you're going to wrap it in the embrace operator. So kind of loosely speaking, this is an instruction for your function to kind of take the bare name that you're passing here and sort of insert it through, I guess, almost kind of like inject it into the function. You can almost think of this as a blueprint, right? If you're familiar with the glue package, you know, this might be kind of an evocative operator here, where you're expecting that this is a templated function, and you're just simply going to replace where you find var, whatever the contents are of var here. Var here being a bare name, so that if you, for example, pass it, let's imagine we're working with the MT cars data set, and you pass it the argument mpg is the var, you're just going to summarize var mpg, and mpg will be substituted here where you find the embrace operator around var. So here you're forwarding a single argument from your function, the outer function, to the inner function here, because you know, the function, you're capturing this operator. It's the object that's expected by this function, and it has the same behavior. It's data masking. We're referring to a column in the environment of the data set, and then summarize will perform its tidyverse magic.
So this is like limited dots, I think, right? So
What do you
like,
mean by that?
so I haven't used, so I always use dots. So that's the next one, just because I always just pass it straight there. But
Okay.
I'm trying to figure out when I would use this, because I think you
No,
can't
I use
name
this
this
a
function.
lot. So, I mean, and you can use this in functions anytime, except the limitation being you can only send one column name here.
And you can use an
But-
expression as well, right? You can use like mean MPG or something if you wanted
Yeah,
to do
and then
MPG.
you would use this var with embrace operator, and then the walrus operator equals, right? And then whatever you want to assign it, you could do that way, you know, in terms of using it. So you could use this inside mutate, group by, select. So for example, you have a certain fixed variables that you want to select, and then one dynamic variable. Then you would say, you know, variables x, dplyr select xyz, and embrace operator var. And you know,
Right.
potentially that goes inside a ggplot or something.
But
But
in
yeah.
this case, you can't name the variable that you've just summarized, right? I think.
You can, but I mean, not programmatically, but you could. Sorry, I'll just bring okay, if my
Like this
computer
just
will,
passes the expression itself. If you
yeah.
wanted to use like summary or mean equals mean MPG, it would not work, because that would be trying to pass to a different argument altogether. So you'd have to name it. Yeah, you'd have to hard code the name inside the
Oh,
function.
yeah,
Exactly,
yeah. Or
exactly.
Okay.
maybe do it with a cross or something. Although it is
And I
one.
think you might
But,
be right.
oh, yeah,
I'm not
right,
sure
right.
about that. Actually, this may not be necessary because this is hard coded, so we might be able to get away with that. It's been a while since I've done this, but yeah, I mean, you're right, Tan, that you know, you'd have to hard code this bit, and the only thing that you're passing is the variable in this particular case. If you wanted to have
var name, yeah.
Yeah, var name out.
Yeah,
I mean, very uninventive.
Yeah.
Uninventive. Then you'd have to do something else. Then
Yeah, I
you'd
think
have
a
to do something
walrus there
else.
would work or something
Yep,
like that. That
yep.
makes sense.
What?
So if you put var name out there and then
And-
change this to a walrus operator,
It's called walrus?
Yep.
yeah, if you look at the eyes and it's got a little equal sign,
Yeah,
if you turn your head
alright.
this way,
Call
walrus.
it fair. Okay.
I think I've always called it walrus, and I think that's the like code name. I'm sure there's like an
Yeah,
actual
it
name
is.
for
It
it,
is, yeah.
but like everyone calls it walrus.
I
Okay,
think we
thank
might
you.
actually have to do something different in this particular case because,
Try it.
yeah,
Let's
we'll
run this
see.
and see what happens.
Yeah. And
Is this
sorry.
VS
We'll
Code?
actually need to do more than just define the function, I think. But
Yeah, you have to call the function
Yep,
too.
exactly. My summarize and let's
Empty
say
cars.
data empty cars. Data, sorry, whoops. Var equals MPG, let's say, and var
spelling.
out my
You have to correct the
MPG.
spelling.
you've
There's no
spelled MPG
MGP.
incorrectly.
Thank you.
And do mean MPG, maybe.
Okay. Oh, sorry, that's okay, since I've got I'll just do that. Redefine my function. Come down here and
Oh, you didn't give it a
it did
summary.
work.
You used summarize, but I think you needed sorry.
There's no
You didn't do
group by.
mean,
oh
so it
no,
didn't calculate a
that's
mean.
right. That's right. You're right. Yep. There's no function. Yep. Okay.
So you could do mean like that, or you could pass mean in through var as well.
So that seems to
Oh yeah,
work.
it worked. Yeah,
Mhm.
that's what I was thinking.
Now I wonder if this also works. Oops.
And you would get what sort of error if you skipped the walrus and went to equal sign?
I
Would be
don't
an
know if you would
informative
get an
error?
error. It would just name the thing var name out instead, if I remember
Ah.
correctly.
Yeah. Because so you have to use walrus when your left hand side is also a dynamic value and it's not like a static name.
Var name out evaluates the mean MPG in either way, because you're putting on the left hand side. But if you get rid of the walrus operator,
We'll get an error. Yep.
we won't. Oh no, we'll
No, I
get an
think it
error.
would be weird assignment. I'm not sure error, but
Oh, it works.
question.
Interesting.
It didn't redefine properly. There's an error.
Oh, sorry. Oh, because it's
Yeah, because of
I
the
done
quote,
wrong?
because of the var name out. If you don't, it won't work in the
okay.
left hand side.
Right. Got it.
So if you get rid of them, I actually don't know if you try walrus, but like no embrace operator. I want to see what
Yeah.
happens there.
Then we'll get var name out the literal name. I think
yeah,
that's my
I think so.
expectation.
Yeah, I would think so.
Yep.
Yeah.
Wow, I love it. You guys are so good. And if you delete the walrus, you'll just get an error, you think?
If you
No,
get
I
delete
think that
walrus,
should,
it'll still
that
say
should by
stage it
default should
works.
work.
Okay,
That would
It should still work.
that should
walrus
still work.
with embrace.
Yeah, you
Yeah,
have to have
so
the
walrus helps
embrace
you
to like
to-
evaluate it. Yeah.
Yeah, walrus will allow you to keep your left hand side as
Okay.
So basically,
variable.
this gets ignored. Yeah.
Mhm.
Mhm.
That was the
Cool.
best 5 minutes of my day. Thank you guys. That was very
You're very
informative.
welcome. I mean,
I really
we've got-
liked this live code, figure things out. That really helps cement what.
yeah, for sure. John will be very upset that we didn't do this. Well, we didn't record this as a demonstration instead. But
Yeah. Yeah. Exactly. He'll be sad that
it's not
it's
what
not
he
in the
gets for
code.
not showing up and then letting me show up instead, because I just
I
code
liked
everything.
it, and I was trying to do things on my own, but I was just a slower typer, so it was actually very helpful.
Yeah.
All right. So that's var. Or sorry, that's the embrace operator. Single arguments,
Mhm.
multiple arguments. Something very similar happens. So in a certain sense, for context where you're just forwarding, where you're working in a data masking context and you're just simply forwarding your argument, you can almost think of this as the plural of the embrace operator, I guess would be one way of
And so
putting it.
Tan, you just prefer to stick with the plural situation even when you just need a singular?
Yeah, I think this is just always Like
This always
even
works.
when this always works, and it also always works when even without a dplyr context, if that makes sense.
Mhm.
So this works because it's like the previous one only works if you're working with dplyr.
Mhm.
This will always work even if you're not working that with a dplyr or tidy eval function. So you can always forward like that.
Okay.
So let's say you're working with data table or something, you could still pass dots this way.
Okay.
Cool.
So, but then when you pass dots and you're performing certain operations, so for example, after group by, you would expect a summarize. And if you want to pick up one of those multiple arguments, then how would you go about that? Or can you? I think is the first question.
I mean, I guess the benefit of the embrace is that well, you're restricting users of your functions to a single argument, and so you can write your code accordingly so that it works in the case where you're only providing a single thing, right? I guess both the benefit and the problem of the dots here is that you don't have any control. Well, it accepts everything, right? So it's a good thing in the sense you don't have to be very specific, but it could maybe be problematic in certain contexts if users of your functions kind of pass to it things that your code doesn't anticipate.
So I'm gonna try and rephrase my question. So for example, in this case, we say dot 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 in the function definition, and then we're passing cycle and am as
Yep.
two arguments.
Yep.
And then we say group by, it's gonna take up both of them in the group by statement.
Exactly.
And I think so. I think what I see different from the way I use it, I use these things inside my function is, and I kind of don't like that approach. Is I have to pass the vectors when I have to pass column names, and this is the bare names. I think I just heard from your presentation. It's called bare names or bare column names. That's how you refer it.
Yes, I think so.
Yeah, because if I mean, the way I have been using them so far is inside a group by, if I have to use multiple columns, I would have to do triple exclamation, rlang, colon, sims,
Yep.
and those, that vector name, and which the vector contains the column names, let's say call underscore names, for example, is its name, and it'll be call name equals cyl in quotes, comma, am in quotes. And I mean, it kind of works, but it doesn't, I mean, continuing to work in the dplyr mode, it doesn't sort of match mentally, to what you're trying to do, and kind of not my preferred way. So this looks interesting in that sense, that at least, these are all bare names and I don't have to create vector and whatnot.
Yeah,
But it would
I'd
have
kind
to be
of done
something that
kind of
is
done the same
always
thing
used
as
in a
you.
group
Yeah.
like this. Like all these will always go together, whatever arguments you're passing.
Yeah, your dot's going to be used as the arguments to one function, really. So there is a way to like pass it as all the arguments into like one argument as well, which is you do like C dot dot dot. But yeah, this is general. I try to avoid bang 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 and bang bang as much as possible because I think it like it evaluates in context, but it's harder for my mental model, and I just kind of stick with dots where possible or collecting it into a list and then using the list, which I think we talk about somewhere here.
Yeah, we do. It's interesting though that like we haven't talked about bang bang or bang 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 very much. I mean, the vignettes we've looked at, I don't know, maybe kind of an aside that's I guess maybe a complaint is I feel like even the introduction doesn't really talk about that very much, but perhaps it's because those modes of operation are not maybe kind of like soft superseded, if I could put it that way, in the sense that
I
they're
think
better,
with the
there are better
embrace
solutions
operator,
available.
yeah, probably they were superseded by embrace operator. Although I still
So-
find solutions on Stack Overflow using them because
Yep.
I guess it's been the older one, and B, because it still allows you to use both single or multiple column names, for example. So I think if it's one, you would use sim, and sims would take care of single and multiple, one or more variable names.
That usually works. I think we'll talk about that in a
later
separate
section,
vignette.
yep.
So that actually falls into metaprogramming, which I try to avoid usually. But basically what that does is it's evaluating your code and like doing programming over your code. Where these just pass your code forward in different ways. So forwarding names is slightly different. So if you do the quotations, whatever, the name patterns literally are functions that like accept names. And then bridge, one to the other. And then metaprogramming is when you do like evaluation over what you've typed. And that's where like sims and quo and whatever comes in. Data mask programming is like a higher level than metaprogramming and like diffusing and injecting. So we'll get there because I think you signed up for presenting it. Actually.
I think
Someone signed up to present
I
something
should
like
have
that.
done for this one, not that one, but okay.
Yeah.
So Tan, you mentioned names, so I guess we'll march
Push
steadily forward for names.
Yeah.
Yeah. So for names, as you said, this is basically where your let's say like the tidyverse function that you're wrapping, to kind of talk in a practical sense, takes strings or kind of like a vector of column names, and so there again these two cases where you have one name and then when you have multiple names, and the solutions are slightly different or could be slightly different. So for the one name case, there's actually maybe a solution that you wouldn't have seen. So if you're writing in tidyverse, you'd have just the bare name right here, where you're writing the unquoted name of a column that exists in empty cars. Kind of a data masking-ish approach might be to say, well, okay, let me say that this is a data variable that exists within the environment of the data set, and I'll kind of address it with the dollar sign. So still, so far, these are in a sense like bare names. So this is kind of unquoted name without reference to the data set that it belongs to. This is a kind of a little bit the same, but we're utilizing the data pronoun to at least disambiguate the reference. So if there happens to be a SIL variable in the global environment, we're not calling that. Instead we're referring to a column in the data set. And then the last thing, and this is the thing of interest, is that you could do something like this. So you could refer to a column. So first you could create a variable in the global environment that captures your variable, let's say cylinder in this case, and refer to it in this fashion. So you're saying that this is a variable that exists in the context of the data frame, empty cars, and then where you find var, you would basically be substituting in the string itself. So in this way, your function, imagine you have a function that wraps this pattern. Your function could accept a column name as a character vector, so kind of like a one element character vector, and then you would forward on that character vector in this fashion, right? So this might be of use. I don't know. For me, maybe like developing a Shiny application. If for example, you're selecting a variable and Shiny passes back a string, perhaps it might be convenient for your function to consume the thing that Shiny Shiny is passing it, namely a string, right? Or a character vector. So this is how to do this to forward names in the case where you have one name. I'll stop here, see if there are any questions, comments.
So this is just in contrast to the section 3 ago about forwarding with curly curly. So forwarding with curly curly is just
exactly the difference. Yeah, this would be like forwarding a bare name, right? Where your function takes a bare name in the column, and here this is where your function takes a
The string.
a character string. Well, rather I should say both your function and the like inner function that you're wrapping could take a string. This is how you can forward on what you're from your function to the inner function that you're wrapping.
Okay, and the language to describe those two, the first one is unquoted,
Yes.
Unquoted or bare names, yeah.
unquoted or bare, and this is just
Quoted.
string or
usually.
named or character
So
name.
you're passing it a quoted
sorry.
name, or it would be a string or
Okay.
character. This actually is the one I usually prefer to try to get to, but it kind of goes back to what we talked about off the top, where tidyverse has this way of making it convenient by trying to accept bare names instead of quoted names. You would be taking back some of that convenience and making your users provide quoted names if you're gonna use this pattern. But it is generally better. For example, if you're using it in a Shiny app, it always comes back to you when people select, from a picker or whatever, they select SIL and MPG and HP. Those come to you in that input argument as a character string, and it's not quoted usually,
Mhm.
which
Wait,
is
it's not
why.
quoted?
No, so
Oh.
if you have like a select input in Shiny, and you get the user to select 3 things, you get a character vector.
Correct.
Okay.
So then
So
those
it is
would be,
quoted. Sorry, did
Okay,
I say
okay.
unquoted?
is
It
quoted.
is quoted.
Okay,
It's a
okay,
character
yeah.
string that is
I'm on
quoted.
board. I mean, I don't
Yeah.
use Shiny, but character strings make sense. But
Hmm. Yeah.
we don't
yeah,
develop-
because quoted makes it a little complicated, right? So you can't use the previous one, and it works like this. But then this approach also is, as it says, the single variable. One name as in single variable, right? That's what we're saying.
Exactly.
And I just realized while Arthur you were talking, I think this approach could make it very easier from functional programming point of view. In the sense, and I'm just thinking of how it can ease my life when I'm trying to translate something that I test in the dplyr mode first, and then say, okay, this is working, now I can make it a function.
Mhm.
And so when so for example, in general, I would probably do this first approach, and I'm like, okay, this is giving me the right answer, and fine, I have a few other pipes after this, and I'll say, okay, this is working, let's make it a function. Now if I translated this first line into the third line, it would work when I assign the var as this value and then check that this line works. And then it's easier to then, make it a part of a function, because it's going to work as it is without any change in the function as well. So I think I really like it that way.
Okay. Yeah, I could see where maybe this might be interesting or useful in, say, like a context of some kind of map function where maybe your x, your dot x is a character string.
yeah, I definitely
Yeah.
can. Yeah,
It also,
thank
if
you.
you're in a function and it's a character string like this, you can also check that it belongs to a known subset of like acceptable arguments. So you can do like
Mhm.
match arg or stop if not
Mm.
part of this set. So you can basically do like assertions with
Right.
this, because you can assert over a character name. But with the forwarding pattern, you wouldn't be able to do any assertions. It's like dots. There's like more flexibility. In exchange, you have to struggle a bit more to try to understand what it is.
Yeah.
I think. Yeah, I think we're good with this.
Okay. So from one to so for here we saw that we have this kind of little pattern where we could do dot data and then kind of double square brackets and insert the name, the character name. So if you wanted to do this in the plural sense, you have to do something different, because as they point out in the vignette that data there's no plural of dot data pronoun, and I don't know, my immediate reaction is, but isn't data already plural? But anyway, I know what they mean. And in this case, actually, in a certain sense, if you kind of have like a matrix of like problems and solutions, I think the short of it is there's no solution here, right? That's not a bridge, because they give this example, but it ends up being the bridge pattern, at least by my reading. But here's how you might want to handle this problem. So let's say you had multiple strings. Sorry, you have a character vector of multiple containing multiple variable names, quoted variable names. So like this, then you wouldn't be able to kind of to forward things in basically. Instead, you'd have to go in a roundabout way that would look something like this, and we'll come back to this in maybe in greater detail, time allowing. You'd have to be a little clever and think about how could I pass something, like some intermediary consumer function, what I have, namely a character vector of variable names, quoted variable names, such that it could be transformed or consumed by my target function. So here, with pivot longer, there's a calls argument, but the calls argument doesn't expect a character vector. Instead, it expects a tidy select. So what we need to do is say, find some intermediate function, in this case, it's all of, that accepts character vectors and sort of performs a tidy select behavior that this calls argument could expect. So in effect, like as I said initially, is if you want to forward multiple character column names as a character string to a consumer function, you're out of luck, and you need to look for this bridge pattern. At least this is my reading of this little section here. And so it's some bridge pattern, or this which we haven't talked about or looked at yet, is kind of transform what you're passing into symbols, and then somehow inject those symbols and evaluate those symbols in some consumer like inner function. So that's where it gets to like what Priyanka was talking about, is maybe sims and bang bang bang. Be pretty, but it works. Right. So on to the bridge pattern. So I think that the vignette summarizes it nicely, and so I've just reproduced the text here. So sometimes the function you're calling, so basically what I've been calling the inner function, does not implement the behavior that you would like to give for the arguments of your function. And so the general technique consists in forwarding arguments inside a context that implements the behavior you want. Then find a bridge that find a way to bridge the result to the target verb or function. So in other words, I don't know if anyone on the call is kind of a board gamer, but I am or was. And oftentimes there's like taking one commodity in a game, you're transferring into something else to get a third thing. And this is kind of the same idea here, that you've got a few cases where you have your function's arguments exhibit a certain behavior. You want them to exhibit a certain behavior, but the function that you're wrapping expects something different, and you need to find some means of taking what you're forwarding and then transforming it so that it can be accepted by the function that you're wrapping. And there are three common patterns that the book, or rather the vignette, lays out. Selection, tidy selection to data mask, names to data mask, and then data mask to selection. And we'll try to go over as many of these as makes sense to do so. Although I'm pretty sure by one example you'll get the flavor for it. So let's imagine you're working where your variable has a tidy select. You want it to exhibit tidy select behavior, but the function that you're wrapping expects data masking behavior. So again, outer function here, let's say call my group, expects selection, inner function expects data masking. So in the case of the vignette, you've got group by, which expects data masking. So you need to build a bridge and find some means that find some function that will accept arguments of the behavior that you are capturing with your function, and then translate them into kind of inputs for the function you're wrapping that exhibit that function's desired behavior. And so here's a little use case. So if you wanted to do to take your tidy select with variables and then pass it on to group by. So you've got tidy select on the outside and then data masking on the inside. One solution here is to basically use the across function. So across, I wonder if this is actually going to be something that's going to get deprecated hopefully not. Across like normally is used for sort of like map type operations, performing like applying functions to selected columns. But one interesting part about it is that it also performs like it returns a tibble. So basically it expects it takes the, sorry, this should be on a new line, but it takes tidy select in its argument and then returns a tibble, which is what you would want in this context. So let's just walk through some code here. Imagine you have this myGroupBy function that accepts a single selection. So you'll have the selection, you can pass it here. Across will accept it as a selection and then return a tibble that GroupBy can accept. The more interesting case, I think, is with multiple selections. So this is what I think Tan was referring to earlier is, let's say you have these 3 dots where you're in your function, you're expecting a tidy selection pattern, but you need to somehow convert it. And so working kind of from inside out, you have your tidy selection that's going to be passed, is forwarded on. You can wrap it with the C, which still makes it a tidy selection. And then across expects tidy select and returns a tibble, which is the thing that GroupBy expects. So even if you don't follow this particular example, I guess the general idea is that we're no longer forwarding, but instead we're taking inputs from one function, or in our function we're taking an argument that has a certain behavior, and then we're passing it to a function that we're wrapping that expects a different behavior, and we're trying to transform our function's inputs into the type of inputs that the inner function expects. So I'll stop here. I know that's a lot, and yeah. Sorry, am I still connected?
Yeah.
Okay.
Yeah, sorry. I'm refraining from asking 10 questions with 2 minutes. It's clear-ish.
Okay.
It's great. Thank you.
I'm always kind of like wondering why you would, like, when you would need this. Like a lot of these feel very theoretical, so I know I appreciate like the trying to keep a practical thing, but like I haven't really come across, like, a lot of this is like, just because you can doesn't mean you should kind of deals, But I haven't really, like, I mean, I'm sure, especially when you do tidyverse stuff, like it makes sense. But for me, it's like, okay, but why? And like I this is a struggle with a lot of these things. So I feel like at this moment anyway, I'm kind of like, I will figure it out. But I know it exists now, but I don't know why. So
I'm kind of in the same boat, Tan.
Yeah.
I mean, at least for these examples, I mean, perhaps in future I'll run up against a problem, and then maybe this will be a solution that'll spring to mind, whereas it wasn't a solution I was aware of at all. And so maybe I could do this instead of my usual utilization of kind of air quotes old rlang of in quo and in quos and bang 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 bang. Yeah. So I mean, we've got a similar pattern here. And we're basically out of time, but just to kind of give you a little bit of the flavor is, the setup is very similar. It's just the only things that change are, we're passing names, so a character vector containing names of columns, so quoted names of columns, and then the function that we're wrapping expects data masking. So back to GroupBy in this particular case, and so our solution looks very similar. So here we could use kind of all of, which takes takes a character vector, performs tidy selection, so it has a tidy select behavior. Then with that tidy select behavior, that's something that a cross accepts. So it takes the selection and then returns a tibble, which ultimately is the thing that group by will expect, right?
So this is useful if you're doing, this is kind of like Priyanka's like shiny thing where if you select two variables that you want to group by in a character vector, this is how you would translate
No,
that
that's true. That's very true.
instead of triple bang, bang, bang. I
That's
think
true.
that's what I'm reading. So
No, I think you're right. I think you're right. I guess for completeness, why not? We're over time, but still.
spend 2 more minutes and we'll go through this. Go.
All right. So last setup is data mask to selection. I haven't revisited this one, so I'll kind of go through this with you guys. So here, our function, we've got our ... we're going to, for whatever reason, we're going to use data masking, but the ultimate kind of consumer of the inputs that our function is providing is something that expects selections. So we'll create my pivot longer, which wraps tidyr's pivot longer. Now tidyr pivot longer, the calls argument expects some what do you call it? Expects tidy selection, right? So here's one way in which we could get from the thing with which we start to the thing that we need. So step number one is forward the dots. Here it's a transmute. So we'll create some data set. So the only real reason that we're doing this is not to obtain the data frame, but instead just to get the name of the columns that are basically kind of kept after this transmute operation. So we can pass here bare names. Transmute will effectively keep those bare names, as I understand it. We capture those names. This is now a character string.
Is that their example? Like that's the most efficient way to get the names of your dots?
I don't know if that's the most efficient way, but this is their example.
Okay.
Yeah, I was thinking the same thing, Rebecca, when I was reading this example. It's like, this seems
I'm so confused.
contrived.
Why would you do that? So if you take data, you do the transmute with the dots, and then you name it data, and then you take the names of that data, and then you pivot all of them, that would also just work. I'm pretty sure.
So say that one more time, Tam.
So mutate and transmute do the same thing, right?
Yeah, exactly.
So
I mean, except the transmute just keeps only the variables that you create.
Which you use in the last bit in order to,
Yep.
that's what you want to pivot on. Yeah.
you would pivot on the
dots.
dots.
So basically the names that you're passing here.
Ew. Okay. Then so if we're doing that, then I would be like, give me the difference between the names that you've just transmuted and the original data argument, and then pivot everything else. But okay, all right.
I think you could do this a different way too. If you basically took these and then made a closure out of it, and then you take the names of the elements in the closure, I think that would work too. So you wouldn't have to go by transmute. I recently did this or something. Because I mean, basically the central thing is you need to get a character vector of names somehow, and this is sort of their solution to get that. But there might be a different way. It's just I guess they haven't gone over closures yet, so perhaps that's why they're not suggesting that, and also maybe it's not the best solution.
I feel like it should be more like this. I don't know, something like that. But it just looks dumb. Like, oh, I this whole thing just like, okay, like we're really stretching here.
Lionel wrote this vignette according to Git history, and he knows what he's talking about, so there must be some.
So that just means somewhere, someone made Lionel write this code. And we need to blame that person because Lionel can't do wrong. So it's more like, what edge case came up that they needed this? It's my real question.
Yeah.
Incredible.
Because this seems like kind of like conceivably an expensive operation, right?
Yeah, that's what I was
Yeah.
super.
In like in a general case.
Yeah.
All this to not just multiply AM by 100 first before pivoting.
Exactly. Exactly.
Incredible. All right. Cool. Good
And there you
to
have it.
hang out with
Thank
everybody.
you.
See y'all next week, I think.
Thank you
Am I
guys so
around next week?
much.
Yeah, of course. See you then.
See y'all later.
Bye.
Bye-bye.